Hi guys, and welcome back in the sheet metal workshop. And in this video I like to show how to make a T-pipe flattening, flattened T-pipe. So I have here in front of me on the table an example of a T-pipe with one side flatted. It comes on diameter 200, and the T-pipe is also got a diameter of 200, and this is the template I've used. We're not going to make the pipe. I'm only going to explain how to make the flat size in it. Okay, let's get started. Now, I have here an isometric paper with isometric lines, and I have here also symbols. These symbols we are using here in Germany. So we have here male swage, female swage. Here we have an end, not an end cap, an end plate. Here we have an end cap. Then we have the direction, in what direction it's going to be fit. Here also some symbols about swage, back swages. Here you have the seam, and here it's a T-piece. And here also flattening with also the seam side. Okay, now the pipe standing in that direction, so I'm gonna draw a dashed line that represents the pipe, and it's got a diameter of 200. Now here's a symbol for a T-pipe, so now I'm gonna just pull a line. That's the T-pipe, and we have here those elliptical forms that we put in the direction of the isometric. So now I want to draw in the seam. So the seam is here, the swage is here. So when it's drawn like this, we always draw it so you can't look into the seam. If it is drawn like this, you look into it, and now you don't look into it. So that's why I use this symbol, and it will be like that. Now the flattening is directly on the upper side, and the 200 diameter. So if I measure here, I have 170. Here we have 200. That means minus 30 millimeter. So then go back here, and I also make here this line with the same direction as the isometric paper, and just here make this and minus 30. Now we have here a female swage, and that's a symbol here for a female swage, so that means here comes an X. Now the diameter of the T-piece is also 200. Now the only thing what's left is the length. Now the length we have here, when we put off the swage allowance, we will have here exactly 150. 150 from center pipe till the end of the T-pipe. So then I write here 150. So now what you also can do here is make a little bit like an arrow. That's optional, but now my drawing, my isometric is done. That's the way we here in Germany draw a T-pipe with a flat. So what we're going now to find out is the minus 30. Now I have here metal, so I'm gonna pull first 5 mm working line. and then these minus 30. So I'm going to put here 35. And I'm going to make here a line. And what I do next, here's my 5 mil working line, and this is 30 millimeter. So my radius from diameter 200 is 100, so I go here from this 100. And now I take my bow divider and draw yet my diameter. So now I have here, I will make this line visible. So now this is my flat. So the only thing what I now have to know is I need this size and I need this outside size. So this we're going to measure. We have here 71 millimeter, and for the outside diameter I have a flexible ruler, and there we have 79 millimeter from here till here. So that's a difference of 8 millimeter for only a half. So the complete flat between this whole straight line and this bow is in complete 16 millimeter difference. Okay, now I have here a metal and I have a template. So if I put it on each other, it's exactly the same size. It's the circumference of 200 plus 2 times 50 millimeter overlap. So it's the same size. Now for the flattening, there's 60 millimeters, so my metal is going to be 60 millimeters shorter. So what I do next is I'm gonna mark here 16 millimeter. And cut it off. Okay, this is the metal. So the difference is cut off, so you can here see it's shorter. So what I'm going to do next, because the flattening is on the upper side, that means it is like this, it's exactly in the middle. So now what I have to do next is find here the middle line, the center, and therefore I have here 66 in diagonal, that means 33. So that's my center, and here I'm just gonna pull a small line. So what I do next, I'm gonna take here this template what I've drawn before and put it here, so like this here, parallel, and then I can drag over this point and this point. So now the flat size is in position. I'm gonna check here. So 249 in here. Okay, also 249. Okay, good. We're good. Now, next what you do is you take your template of your T-piece, put it in position, so it is 150. Now my template is also 150, so I'm just gonna put it here. I can also give swage allowance, but that's optional. Now I'm gonna drag here first those holes. Here give it a little mark, and now because on the template is no stretch allowance, so I have to give about 15 mil stretch allowance. And now I'm just moving the template left and put it here on this side, equal, line up, and also do the same here, lines, here just a small mark, and also the stretch allowance. Good. So next what we do is, so these are my 2 points. That's the straight line. So I'm just gonna see, that's the straight, the flat. And I'm gonna also give 15 millimeter stretch allowance, so 15. And that's it. So I'm gonna put out first those holes, make those holes, and cut it out. So now I'm gonna snap here a little bit until my 15 millimeter stretch. Here also a little snap, then also a little bit here. Okay, now here's my T-piece, so that means the flat is from this side, and I don't want to look into the seam, so here comes a normal swage, and up is the X, is the symbol for female swage, so I put here an X, and here for information just minus 30. So now I have signed my metal, and the next thing what I also need to know is the angle. Now if you have an angle measurer, then I'm gonna put it just like here, and so we have here 48 degrees. So this angle is 48 degree. Okay, now what we do next is I'm gonna fold it both sides, put in the swage, round it, put screws in it, and make a female swage, and then at last we're gonna stretch it. So I'm now here on my folder machine, and here I have a Scala. So we said 48 degrees, so I'm gonna leave a little bit more, 50, and this side also. So next what we're going to do is put in the swage and round it. Okay, now I only have put in the screws. Okay, and then here a little bit here, a little break, so to get it a little bit more in form. And that's it. So what is left is stretching. That's a female switch. We marked it here with an X. Okay, these are German symbols. Okay, the machine is set up. I have here 15 mil stretch from the wheel down until the plate, 50 millimeter, and this is aluminium zinc, 0.6 millimeter thickness. So everything from here is just a normal T-piece. So when we come here in this small area, I'll give here more power, and here I'm pushing it in this direction. See? Then a little bit less, and then here only a little bit. Okay, that's one side. Here also again, so I'm pulling this here. With a little bit more power. Here we again a little bit less power, and then here just the form. Okay, that's one part, and now I'm gonna make those loose, those wheels, and just here where they start touching each other, you go a little bit. And there it is. Okay, let's see how it fits. Well, that looks good. Okay, that's it. So here's the sketch. These are German symbols. I think it's a good system and it's easy. Once you know how it works, it's really easy. And okay, that's it, what I wanted to show in this video, guys. Thank you for watching, and see you in the next video.